you plant those seeds early, and so then when they get to the middle school and they get to the high school, it's like what we do is so powerful, and so in those early years that's transformative, and that speaks to, well, you know what, I am going to share because I know that there's a really cool career in the future for me if I stay strong in my math and science. So there's just a lot of research that just backs that up, that if you can get to those girls basically 5th grade. That's
somebody else here told me that they're reaching down into the elementary schools, and that's one of their marketing strategies right now to get them young to address this.
I concur. We've been talking about this, and workforce development hired an outside consultant to research across the country about this industry, HVAC, building automation, how many jobs are going to be needed, the pay, and it drills down even in each specific area. So, there has to be a paradigm shift in how we recruit. I just say we go to the high schools, we've been doing that. So we're going to have to start going to the elementary schools, and not only to tell them how important the industry is, but really diagram how they trek from elementary school to junior high to high school to each respective trade, what's going to be needed. And then we can have the support of the parents too.
And support of the parents is really critical, and that's why I go back to what Chris was saying yesterday and thinking how critical that is, because I know full well that my brother, who has an associate's degree, is making as much money or more than me. And I've got a master's degree in engineering. So, money shouldn't be the object. It should be pursuing what you enjoy. Really, it should. So,
I have a couple things to say about, my degree is in mechanical electrical technology with a concentration in HVAC. During getting that degree, I would go to something like a solid state applications course that would have people from all different trades in it. And you'd get a bunch of different ways of looking at the same issue from many different perspectives. And you would end up covering some things that might not be in your trade today, but 5 years down the road, when I ran into some new technology in HVAC, it was something we had talked about back in solid state applications 5 years ago. I at least had an inkling of how it worked. We have done so much in higher education, in my opinion, to silo everything into the chute to process somebody at this end through that chute out the other end with a very narrow focus, that it's begun to fragment the entire industry. And part of that problem is that now students get into the chute and they can't get out. Or they get out, they got to back out and retake a bunch of classes.
And who wants to do that?
And in fact, you have teachers teaching classes with 5 or 6 students that are almost exactly the same curriculum as another class down the hall for another department that has 5 or 6 students. And that's almost the same. And it's such a waste of effort and energy that it makes the whole thing very inefficient. But we get very focused on, we want our students to know exactly this, as though we know what they're going to need to know in the future. And it's not true. Many things I learned that I thought I would never use, I use. And many things that I thought were going to be very useful to me ended up in my career not being useful at all. I know I'm getting really excited about this, but this is very personal to me. This is my life. So I think I got a perspective that's worth sharing. That's all. Thanks.
Well, maybe just 5 minutes and then we'll introduce Project. Dave, and wait patiently.
A couple things. On the recruiting side of things, we were talking about going, outreach with the schools and whatnot. I think one of the things that we're missing is we're talking to the students. I think we need to be talking to counselors. I have done career fairs and job fairs, and we're not being presented with the cream of the crop, so to speak. There is an old mentality out there that, well, if you can't make it in college, there's always the trades. We need to impress upon them, this is a skilled trade. There is a lot of science. There is a lot of math. Yeah, you're going to use your hands.
Bring that pickup truck with that board on the back of it.
Exactly. And the other thing, we were talking a lot about certificates and whatnot, and kind of back to, what was it? Yes, what we were talking about earlier. I think what that is doing, I think especially at our school, what we're kind of masking with that is what's happening is people are jobbing out. There's a demand for the people, and so in the last semester, employers are snatching them up, and that's causing them to not finish. I think back to our advisory committees, if we're going to have the contractors represented on that, impress upon them that we have the expectation that you're going to let them finish with the program. Please don't try to snatch them out halfway through the last semester just because you need a body. You know. Robert?
Has anybody tried cracking into the makerspace?
The what?
Makerspace. Fab Labs, and there's a whole community of folks out there that are just taking, you know, small things, Arduino, microcontrollers, Raspberry Pis, building, you know, 3D printers, that kind of space where these people are just out there doing this from kindergarten and up to, you know, people in their 60s, 70s, 80s. And I think that has the potential to be, I mean, obviously we're not going to get people who already have a good paying job. But if we catch in on the lower age end of that market, or on the even potentially retired market, that might be a...
Yeah, could I just respond to that? That a few months ago, as part of outreach for our high school physics for building science class, which has been at Laney College for 10 years, I visited an after-school program called Tech Bridge, and it started in Oakland. It's been there for at least a dozen years. They've now opened up offices in Seattle and Washington, D.C., and they focus on STEM summer and after-school programs for girls. Right. And I don't quite remember the exact, you know, grade levels that it covers, but still, this one group at Oakland Tech, right, they were working in teams, and they were using these Arduino microcontrollers to manipulate lights and sound, and they were doing a little coding. And to me, yeah, I mean, that's definitely an area that is very promising, and you know, the after-school programs, it probably wasn't the first place where I thought to look. All right, so that's one, and then there's another nonprofit called ACE Mentor, that's short for Architecture, Construction, Engineering, and they are national. They are everywhere. They've been around, I think, for at least 15, 20 years or more. And you know, it's open to students generally at what, grades 10 through 12. They work in teams. They often work with students from other schools. This one group in Oakland, again, they only met once a week for one semester. And they, at the end, had to develop a PowerPoint presentation, including a construction budget estimate and a project schedule, present some rendering in SketchUp or the equivalent. And I was really impressed that they were able to pull that off with as little time as they spend. So I would encourage you to look for those groups in your neck of the woods.
4-H is very involved in STEM now too. I've done stuff for 4-H groups.
Yeah.
Yeah, they're not just agriculture anymore.
We can take 2 more questions.
Okay, one area that we've started looking at our college is the people that are coming back to complete their GED.
Okay.
And that's been a big area at our colleges, is bringing in the GED students before they graduate with their GED, bringing them into our programs, walking them through tours and things like that.
That's a good idea.
And then also, we have what we call an early college high school at the college now. This is where we take 50 students out of the local area high schools that may not have the money to go to four-year colleges and bring them into our college in the 9th grade, and they work the 9th grade, and by the time they finish in 5 years, they can have an associate's degree in different areas, and we're starting to hit those kids to come into the trades area. We've had our first student to graduate with electronic engineering, associates in electronics this year, and there was a female student, but she started in the 9th grade at the early college high school. So that may be something that may want to look at, is going to early college high school.
One more person? Matt?
I'd just say we did some integration with the makerspace groups. There was a Lansing Maker Network, and we ended up putting on an event. We basically just opened up our space and some staffing in it. I couldn't say that we got any students out of it, but it was some Google-sponsored event. Sean Huberty, if you know Sean from LCC.
No Sean.
Sean was kind of spearheading it, so he could tell you way more about it than I would if you got questions about it.
Is there a way to connect makers with HVAC?
Well,
that's my question.
What we found out with this event was this was like a competition weekend, a makers weekend, a maker startup weekend. They were coming for some very specific things, but like they had people flying from MIT to be a part of this weekend because of whatever affiliation it had with Google. But so we didn't necessarily, I said all that to say we didn't necessarily go a bunch of students, but we got a lot of engagement with our local area for not a lot of commitment of time as far as our resources. And then there was all kinds of press coverage of it, and it continually said, you know, at Lansing Community College West Campus this weekend, that happened. And then the students created these groups came together, they threw out ideas, then as groups they split up, or as a big group they voted on which ones they should focus on, they split up into those groups. At the end of a one day or a weekend, they presented what they did. One group got voted the winner, and then they ended up getting some funding to like beta test their idea. So it was a really cool event. My understanding is there's a lot of these maker networks, but they're kind of underground across the country. But if you can get linked in with them.
Yeah, I haven't heard of them before. All right.
Okay.
Yeah, one, go ahead.
Just to directly answer Peter's question, how to get them to be integrated into the HVAC, sponsor a competition and just have it be an HVAC related, maker idea. Just do something, say the top 5 people get a Raspberry Pi. You're going to spend $150. You get industry representatives to come in and judge it, and just make sure that the challenge is HVAC oriented.
And tell us what a Raspberry Pi is.
Oh.
It's something that I won't eat. I won't drink raspberry beer either.
Yeah, the Raspberry Pi is a credit card sized computer. It costs $35. You can buy them about 50 different places now. Amazon, Newegg, Newark. You can buy them anywhere. Just do a search for them. And the Model 2 just came out a couple months ago, and it is immensely powerful for the size of computer it is.
Kids can learn programming.
Kids can learn programming. They can deal with inputs and outputs. There are people who use it to control robots. People have done high altitude photography with them. I mean, just the variety of things people have done with this computer is absolutely astounding.
Let me ask Brian a question, Ted.
Go right ahead.
Do you think there's qualitative difference between a student that can succeed, say, in a refrigeration program versus a BAS program?
The only major difference I would say is well, one thing we see in the HVAC controls industry, there are those guys that like to use their hands a lot every day, using wrenches, yada yada yada, and there are those guys that kind of tend more to the computer side. If there's any difference between the two, I would say the controls guy is probably going to, because of the nature of the industry now, have to be really focused more on on staying up to speed on, computer IT networks, et cetera, et cetera. Or perhaps somebody who's working in the refrigeration industry, they're going to be working, right in front of cases every day, just about. They're going to be in the field almost all the time. Even the controls are typically HMIs right on the equipment themselves, usually, like the Emerson controls, CPC stuff. So I'd say if there's any difference, it would be that would be the major difference. What would you think, Gerald, as far as characterizing the set of students?
Yeah, I think the controls of BAS technicians got to be more IT savvy, as we've been discussing, opposed to the refrigeration.
I see them diverging away from the HVAC industry. It's more metering, lighting, electrical. I think it's going to become more of an integration world, and it's going to be less equipment specific. In other words, the HVAC guy may be able to troubleshoot the equipment controller, but he'll need the BAS system to do it, or some other kind of interface. But that BAS guy is going to be more of an integrator.
Mm-hmm. And see, with the refrigeration, especially the supermarket side, is more like that, because whereas in air conditioning, you got the mechanic that sets everything, and the control guy comes in, but the refrigeration mechanic has to do it all.
Right.
I mean, he has the address, the CPTC controller, he has to start it up, he has to write a basic program for programming the cases, how many defrost. So in a limited way, he's doing that on the supermarket side. But I think, as you mentioned, it's coming to that.
It almost seems more like a tool, like the CPC stuff and the Emerson stuff. Seems more like a tool to the refrigeration guy that he uses when necessary. And by contrast, in EDC world, you're really immersed more into the computer side of it almost all the time, and then you go out to the field as necessary. So that's another point.
I think it's probably more.
Let me ask Lanny what his experience is as well.
This guy really needs to stop showing up to
In terms of BAS versus your traditional HVAC program, where are you seeing a lot of people moving into BAS from your HVAC program?
Yes.
That's what we're seeing a lot of.
Yeah, we're seeing a lot of people that are migrating from HVAC. We have, we have courses that are offered through CIS and through that side of the world, IT. But we don't see a lot of people, that want to migrate from the computer side really over to us, because they, unfortunately, I think they still see us, the whole wrench turning thing. You talk about building automation, and then you kind of gear them towards, well, you got to understand what it is that you're controlling, what it is that you're programming, and ultimately, you start talking about these mechanical pieces of equipment, and they're kind of like, I don't know. So, but yeah, from the HVAC side, moving over to BAS is what we're seeing. Do you pursue them? Do we pursue them for computer? We don't, we don't aggressively pursue them, but we do go over and talk to them, if you like computers, our industry does have a niche for you. It's a little bit different than what you might, originally have wanted to go into, but, we do have a nice side of the air conditioning industry, and so we talk to them. So we give like little class presentations, and, we may get one or two of them coming over, but that's about it, and that's in a year.
So this is a really rich conversation, and we're going to circle back a little bit later, maybe and continue this over dinner. But Chad Dunn is here from TriTech Corporation, and because Jim couldn't make it, as is typical in the automation industry, emergencies popped up, Jim wasn't able to make it. So we sent Chad over here on, 5 minutes notice? And Chad doesn't have a computer plug right now, or a power plug. So the presentation is probably going to go as long as your power holds up.
Probably so.
Okay.
So we should be all right. We should be fine. You have a Dell.
Oh, you said Dell, yeah. We got a ton of Dells around here, so.
Okay. So let me give you just a quick.
There you go.
So, thanks, No, not right now. We're going to jump right into the TriTech presentation first. So let me give you a quick little history about TriTech. TriTech's been in the Atlanta area for quite some time. I remember using their stuff when I was a contractor. That's how I learned about them, because they're really into the isolation room monitors, fan monitor stations, high precision stuff. And Chad has been with them for that entire time. Actually been in the industry longer than I have, 25 years now. Yeah, so TriTech was really good to us, even going back to the R.S. Andrews Academy, which was a satellite campus of GPTC, then DeKalb Tech, that Gerald set up. TriTech was there for the opening of that. I don't know if you were there for that. So I was too. So our history goes back a long ways as well. But they've been a great sponsor of our program. We have a lot of their products. And as we saw earlier in the day, they are BACnet compliant. So they work well with the ALC stuff. And I'll let Chad give you the history, but yeah, it's good to see you. I don't think it's been a few years.
It has been.
Good to see you. So
I spent the past few years in the Middle East. I was our local rep there. So I've been kind of in and out. So that's probably
yeah, probably so. So I'll turn it over to Chad.
Right, thanks. Well, first, tell you a little bit about our company. You know, we're actually a global company. We're celebrating our 30th year this year in business. We are local here in Atlanta. We're in a suburb called Norcross, Georgia, which is about 35 miles northeast of Atlanta. We're privately held. We specialize in a complete end-to-end solution for critical environments, such as laboratories and clean rooms, pharmaceuticals, hospitals. Anything where you're doing directional airflow control, high-speed control. We have extensive building management system integration experience with all the major BMS contractors through all the major protocols. So all the product has the individual protocols on all the controllers on them. And then we have an install base of 4,000 applications worldwide. Just a couple of applications, obviously, like I said, hospital application. We have operating rooms, isolation rooms, higher education, laboratories, manufacturing. As I said, once again, in any area where you would have directional airflow control or would be a critical environment per se that we're on. Just a partial client list who we do business with. ALC is one of our customers as well, obviously. And then a little bit about our facility. We are a fully integrated facility for product design, manufacturing, assembly, testing, all the calibration. And we also have a training center there as well. If you look here on the screen, this is actually where we actually calibrate our venturi air valves. And we'll get into that product here shortly. This is our demo lab or training lab. We have a fully operational lab with a fume hood. And then our product overview quickly: venturi air valves, room controllers, fume hood controllers, and all the ancillary products that will be associated with those applications. Where critical airflow is required, as I said, clean rooms are a primary product area where we provide those controllers. Basically, any space that you want to produce a positive or negative pressure, right? Hospitals, surgical suites, pharmacy in the hospitals. All these facilities require high-speed pressurization control. Okay. In a laboratory, there's three separate systems that make up the overall variable volume lab. All right. First and foremost, the fume hood controller. We got to make sure that we're maintaining proper phase velocity of the fume hood. And then also a room ventilation system. The room ventilation system has to actually maintain the offset of pressure for the space. And then also the control systems for your supply and makeup air and exhaust fan systems. Typical design priorities are going to be safety being first and foremost, both at the room level and the fume hood level. These systems have to accurately measure and reliably respond to changes, and they have to do it within seconds. Okay, and we also have to do this without any variation or oscillation or hunting. So it's high-speed control, but it's very precise control. All right, and we'll get into some of how we do that here momentarily. Containment is also obviously a design priority. Fume hood level, and make sure that we're removing all of the contaminants of the fume hood so that the contaminants not getting to the end user's breathing zone. And then also the room itself has to be controlled to a positive and negative pressure depending upon the application. Speed of response is critical. Systems must accurately measure and respond instantly to changes, typically within a half a second. So we're using these PID loops and these controllers that can actually control in a high-speed manner. A little different than a typical HVAC application. Stability, as I said before, we want to make sure that the room is stable. So we're doing this high-speed control without excessive overshoot or undershoot. So we minimize hunting. And then, of course, we want to make sure that we're maintaining a proper accuracy level, which is typically plus or minus 5% of CFM set point. Comfort is another, comfort obviously, temperature and humidity control if applicable. And then also compatibility with the BMS is critical. We want to make sure that the building management systems can read and write to these systems. We want to monitor alarms, change set points, whether it be temperature, airflow set points. All that can be done through our system from the BMS as well. Those points are definable, basically. We'll start with fume hood concerns. Dynamic changes can cause fumes to spill from a fume hood. Okay. Too high or too low of velocity could cause fumes to spill from a fume hood. And then we'll get into the options of how we would control them, right? Based on sash sensing. Everyone familiar with the fume hood and how it works? Basically, you have a sash that opens and closes. We're going to maintain a face velocity at that hood at all times. Sash sensing would be an option. Actual velocity sense, we're actually measuring the flow through the hood. A combination of both sash and velocity sensing. We'll get into that control momentarily. And then obviously we have some constant volume applications still out there. Not so much with the way where everything's going to energy efficiency, but there are still a few. This is actually a diagram of a full-blown example where we're doing both sash position control along with velocity control. And we're using a venturi air valve with a high-speed actuator. And we'll go through each of the components in the next few slides. Have you ever heard of, has anyone ever heard of a venturi air valve? Are you familiar with those and how they work? Okay, so for those of you that are not, typically in an HVAC world, you're using VAV boxes or dampers to control your temperature and your heat and your airflow, right? Well, in the critical spaces, those VAV boxes tend to, typically in the critical spaces you have to maintain proper pressurization. You got to do it with very minute control and high-speed control. And also accuracy. The VAV boxes are not as accurate, particularly down at the minimum airflows. With these valves, we actually have they're a calibrated device, and their accuracy are plus or minus 5% in the full range. So we could be 50 CFM to 1,000 CFM, and we're going to maintain an accuracy of plus or minus 5% at all times in the range. Okay. Now these valves are also maintenance-free products. Okay, so in a corrosive airstream, where you have say linens or you have a fume hood application. Obviously, flow crosses and VAV boxes and dampers in a corrosive airstream would not hold up to corrosive resistance. These valves are made such that they are pressure independent and they can be coated with corrosive resistance coatings so that they don't deteriorate in the ductwork. Now, our body's materials are aluminum. We also provide a hair site coating, which is the corrosive resistant coating that I spoke of. And then we also offer them a 316L stainless steel construction. As I said, our mechanical pressure independent valve, we offer two pressures, both low and a medium pressure valve. Lower pressure valve obviously will allow you to run your fan statics at lower pressure for energy savings. We also offer the valves at a full shut-off or partially closed. Once again, driving you towards some of that pressure, some of that energy savings with the shut-off valves where you can shut those valves down for lower air change. So we also offer the valve with an insulation as well. So for your supplier makeup valves where you'd have condensation, insulation would be good for that. Then, as I said, this is actually a slide where you can actually see the aluminum type of construction versus a corrosive resistant coating construction. And then for larger airflows, we would gang valves. You know, we typically see 8-inch, 10-inch, 12-inch, 14-inch diameters. And then, of course, when we get into higher airflows, we gang them together to achieve the larger airflows. We also offer this valve in a universal module, which will allow us for your non-critical spaces, a temperature controls contractor or BMS to control these valves. Some of the other lab manufacturers actually, you get their control system, you get their valve, and you got to use all their stuff. Well, we've broken that apart because we're seeing a lot of building management systems, and particularly colleges, where they want to use their own BMS to control these valves. One, it allows them to kind of control their own destiny, not rely on someone else, right, as a manufacturer. But we're seeing that most of the higher educational institutions have people and staff that manage their BMS and their controls. So this was something that basically, the need was there, and we're actually getting a lot of positive response with this.
Do you have a pneumatic actuator as well?
We have access to pneumatics. I'm getting
we were arguing about pneumatics.
We don't see much of them. I can't tell you the last time I actually provided it's been years since I provided a valve with pneumatics.
What about explosion proof?
We do have, it's special, obviously. It's pretty specific. We've done a couple of jobs in some pharmaceutical areas, Amgen, as a matter of fact, out on the West Coast. It was intrinsically safe, where we had to do some that's when we did the pneumatics, as a matter of fact. Where we actually had to locate all the valves and any electronics that were there, IDPs and things of that nature. We had to locate that in another area outside of the intrinsically safe area. But we did have to do pneumatics. which this guy's going to really love the next slide. This is the upgrade kit. We have a few systems out there that are still pneumatic. Some of those systems with the pneumatic operators, they actually they have. I'm sure you're familiar with pop-ins or solenoids, right? So what happens over time is with these valves, we're controlling it like a 10 to 20 degree swing all the time. It's very, very minute, right? So what was happening with the pneumatic systems where the pop-ins were, they go quickly. They're always changing, right? So we offer a kit now where we can actually go in and upgrade your pneumatic systems.
Our condolences.
It's heartbreaking.
So in our industry, I'll say Grand P is what I'll call them. They did pneumatic systems. There's a lot of those pneumatic systems out there, and we're actually going in and changing their pneumatic systems to all PVC with this kit. This is actually a screenshot of our factory calibration station for our valves. As I said, all the valves are tested for airflow accuracy and pressure independence throughout the full range of each valve. And then, of course, the flow curve for each valve is actually attached to the valve on a label, and it's also stored at the factory. And if there's a controller associated with that valve, it's actually put into the controller type calibration as well. And every one of our products are third-party validated using this traceable instrumentation as well. Moving on to the actuator, high-speed actuator. This actuator, we use about